Okay, so in summary, we talked about symbols that mean round up. Rounding up has the bars at the top only. Those are the only ones we round up on. Rounding down, have a couple. It's either the double bracket, the single bracket, or where we just have the bars on the bottom. Another name for this, if we're talking in terms of function, would be a ceiling. This would be a floor. Okay, so now let's actually look at their graphs. When we graph them, there's two names that we call them. The rounding down functions are called step functions or greatest integer functions. So the rounding down will look at these two ways. The rounding up will look like this. Now, when we think about the parent graph for the step function, y equals the greatest integer x that is less than the given value. So, 0, what is the closest integer to 0? Oh, 0 is an integer, so it would be 0. So if this were rounding down and I plugged in 0.1, 0. If I plugged in 0.28, 0. If I plugged in 0.49, it would round down to 0. So all the x values, even 0.99999999, would round down to 0. But when I got to 1, it would be 1.
What do you think so?
So how does that look on the graph? 0, 0. I got it. Dot right there. Okay, 0.10, dot right here. 0.280, dot right here. 0.490, dot right there. 0.62, dot right there. 0.83, dot right there. 0.9999999999999. Ooh, I can get really close, but can I ever get right here?
9.
No, we got to open circle. We got to open circle.
That German for me.
That was good. I liked it. Okay, so it goes right up to that, but when I get to 1, it's actually 1, jump. But 1.1 would round down to 1, a y value 1. 1.2 would round down to 1. 1.3 would round down to 1. 1.4 would round down to 1. 1.5 down to 1. 1.6, 1.7, 1.8, 1.9, 2, jump.
So this is what we do for like all this?
Okay, it is. It's like stairs. It's like steps.
And you don't
It's like a step function. Yes. And they do not connect.
Okay.
They do not connect.
So like this is
Okay.
this is too time consuming. Can we just like draw lines in the next one?
Yes, that's exactly what you do. So what you should notice is it ends up making this little barbell thingy. It's closed on the left. It's open on the right. So once we do our first one, we think about it jumping to the next integer. Jumping to the next integer. Jumping to the next integer. Hey, we can go backwards to the previous integer. Backwards to the previous integer. And just like you said, it looks like stairs. It looks like steps. We call it a step function. And it is not continuous. You're right. It's not continuous. We have jumps in this graph. We have repetitive jumping. Jumping, jumping, jumping. Okay, so if we talked about the domain of this graph, the domain is not restricted. I could plug in anything I want to for x. All real numbers. Remember, the double R means all reals, right?
I thought that was an IR.
I did too.
Double R.
Will this be like for each time that it's all real, or just for this?
For every step. Yes, ma'am.
For the x values, do you just pick any random ones? Like
Actually, after I create the graph, I'll never do this part again.
Okay.
And I'll show you what we're going to do in a second. Okay, now the range. Your output, your y's. -2, -1, 0, 1, 2, 3, 4. What kind of numbers are those? Integers. Greatest integer. They're integers. Okay, so this is the set of integers. That's a lot to write, isn't it? So, just like there was a symbol for the set of all real numbers, there's also a symbol for the set of all integers. It would be nice if it were I, but it's not.
What is it?
It's Z.
Oh, like that?
It's a double Z. The double Z for Zinni, the set of all integers.
Does that work for every single one?
No.
Your sister's name?
No.
Oh, Zoe. Zoe. Zoe.
You
I
got
can't
it.
think of her. Huh? Wow.
Alright, so, had a question a minute ago, do we have to make this chart every time? No. Because what we're going to do is we're going to think about this being the parent and this single barbell where we start. Now, if there are no transformations on the formula, on the function, we graph that first one, jump up by 1, graph another one, up by 1, graph another one, up by 1, we're good. But what if we had some shifting going on? What if there was a +2 and a -3 right there?
You would go down when you start -3.
We'd start over at -2, -3. And my first barbell would go right here.
And then up and then.
Okay? And then I would jump up and keep going.
Wait.
Actually, I didn't mean to make these connect. I'm going to move it over to +2. +2, -3. There we go. Now they don't connect. That's prettier. And you would just jump up by 1 and keep going. Jump up by 1, going upstairs.
And now you're off the graph.
Okay, and I'm off the graph, so we like to do like 4 or 5 steps. So I might go back 1 and throw 1 down here,
You've done it.
That's fine.
and we're good. Now, interesting things could happen.
Oh no.
Okay? And what if instead of having this equation, we had a 2 right there?
Oh, we'll jump up
Multiply your
too.
y values by 2.
We would jump up by 2! So we graph that first one and jump up by 2.
Whoa.
Now, jump up by 2. Got a little vertical stretching going on
Oh,
here.
yeah, by 2. That's fine.
Go back by 2, down by 2. Okay, now, this case, my range is no longer the set of integers because I skipped some. If I'm jumping by 2, it is either even or odd. Now let's look at the y values. -5, -3, -1, +1. So this is the set of odd.
Is there a symbol for that?
No, there's not.
Well, can we make one?
Just say odd integers. I'm happy.
Can we just make it?
Yes, sir.
So would this be like the same as the cubic and squared functions where if it's inside of the bracket and next to the x, would it be dividing?
Oh,
So that would
thank
be the-
you. That's what I was
shorter.
going to do next.
Today's such a smart day.
Let's do a divide by 3. I like it. Okay, so if we take and something happens to our x, we always do the opposite. So what is the opposite of dividing by 3? Multiplying by 3. And what that does is it takes that original step and stretches it out 3 units. Stretches it out 3. Now, I'm still going to jump by 2,
So
but then I'm going to stretch it out by 3.
So wait, so each one still is like it still starts where the last one ends.
Yep, still starts where the last one ends. Yes, sir.
All right.
Okay? Now, what if, last what if this were -2? Instead of jumping up, we would jump down.
Going up and like to the right, you just go up and to the left. You going down.
You jump down.
So it's like
What you said would probably work too, yeah. Yes, sir.
What if there's like a, there's a one half, like a 1/2 x?
Like on the piece of paper you got? We're going to do that one in just a second. Okay. Now, the other one is the rounding up. It is still a barbell,
It's
but
just
the
reversed.
barbell is flipped.
That makes sense.
Okay? So, here's some things that I've already rounded up to the next integer. Well, -1 is an integer, so it doesn't round. But -0.9 rounds to 0.
Oh my gosh.
Negative 0.5 rounds to 0. Negative 0.1 rounds to 0. All of these negative x values between here and here round to 0. And 0 is 0. But right here at negative 1, it was negative 1. So, the weird part is, if you were to graph this like it were a parent function, this is your barbell. But you start with the closed part and go back to the open. Here we go. This is not shifted. 0, 0. It's a rounding up function, so I start with the closed part, go back to the open one. Now, I'm going to graph a couple of these and then we're going to see if this makes sense. I'm repeating my pattern. I'm trying really hard to repeat the pattern, but my arm is not working with my brain. Open, 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 open. Let's see. I'm going to pick a random point. This one. An x value of 2.5. If I round 2.5 up, was it round 2? Oh, is there a point at 2.53? There sure is. That's where that little bar is. So any point I test will work. And that's what this one looks like. So you start with this and go back to the open.
Yeah, this is easy.
All right. Your graphing calculators have the ability to graph greatest integer functions, but it doesn't show you the open and closed. It looks like little bitty segment, and it's not easy.
Okay.
So I wouldn't use it,
Oh yeah.
but yeah. All right, so we're going to do a couple of these together. First of all, what are you asking yourself? Is it a rounding up or is it a rounding down? This one's up. This one's up. So up starts with the closed and goes this way to the open. So, transforming this. Where does the closed?
3 down.
Right 3, down 2. Good. 3, negative 2, that's where the closed is. Because this is a rounding up, we go actually back to the open. Alright, now, there's no number out in front, so we're just going to jump by 1. It's a normal jump. And it's upstairs because it's positive. Up by 1, normal jump. Up by 1, normal jump.
Oh, you up?
Now, there's no restriction. No restriction on my x. It's all reals. And I'm okay with you putting the double R. Some of you put a double R even when I'm doing interval notation on it and everything. I don't count on for it. I don't know if you've noticed. All reals is all reals. Whether you write it negative infinity to positive infinity in interval notation or you write all reals. All right, range is every single integer. It's all of them. I'm not skipping any of them, so I can do that double Z for the set of integers. It has its own language. You're right. It's like some people feel it's a foreign language.
It is.
Okay, number 2. Is it rounding up or down? Down. It's down. So this is where we go closed over to open.
And you multiply by
Okay?
3.
Now, where is this one going to start?
Left one down. Up
Left one up to closed. Now, this time instead of going over 1, I go over 3.
Almost had it though.
No, right. You said up 3.
No, you said multiple.
Wait.
That's basically
Oh.
multiplied by 3.
Oh, it's
Now, there's no number out in front, so I'm still just jumping by 1. Even though I'm going over 3, I just jump up by 1. I'm gonna do one more to fill up my graph this way, and I'll be happy.
So,
That looks pretty good.
I have a question.
Yes, sir.
What would you be multiplying by 3 in the situation?
Yeah, it's a horizontal stretch. You're multiplying the x moves by 3.
You go out 3.
So domain, but the range is still the set of all integers because we didn't skip any y values.
We just went
Every integer y value is accounted for.
What am I doing?
Now,
So when would do we use it? I was checking it
the graphing honestly is not often used.
What does the function mean?
Actually, the real world application of the graph is not.
Why are you laughing? Exactly was it?
No, it was a real question. I get it. Okay, this one is an up, so it's solid over to open. It's an up, and it starts at -3.
But it only
But-
goes up a half.
It goes a half, and not even up. It goes
Down.
down a half. Little stinker. These are really hard to do. You gotta draw a tiny little one right here. And then a tiny little one right here. I hate these.
Or you can just do it normally.
Hi.
What?
No, you can't.
Yes, you can. I'm doing it normal size.
First time. Are you going the right way?
You take the negative, you say, okay, that means it's going down.
No, which way?
Yeah.
What if it the other way?
It goes down by a half.
Alright, so you
So I had to go down. Down.
It's alright. Sorry, Joe.
Because if it goes up, because if you go up, it'll be going up.
I keep No, I mean I know what I'm Okay. Ow.
What?
Alright. Let's do like,
What's the domain now?
Are they the same?
oh, that's why I did that problem. Hold on. So domain is all reals, but the range,
It's
we can't describe this in words. It's not the set of integers, it's not the set of even integers, it's not the set of odd integers, it's decimals. Look, that y value right there is -3. That y value right there is -3.5.
So you can.
That y value right there is -4. So the way you describe the range is ... Here's a little pattern. ... There we go. There's my range. Yes.
Did we ever learn in graphing where it'd be acceptable to put like an equation for the range?
Joe.
Start talking.
It's not a,
The range is generally described as in interval notation, in words, or as an inequality. So no. And the entity and content though. An inequality, yes. An equality, no. Okay, we'll do like number 5. This will be the last one. Is this rounding up or down?
Down.
Down, so it's solid over to open. Where's that first solid dot starting? -2, down 4. How far over does it go? 2 units. Am I jumping up or jumping down?
Down.
Down, how many units?
3.
3, and I'm already off the graph. That's not very helpful.
That's from
Wait.
straight.
So,
Hold up. Wait, isn't it -2 over? Isn't it? It's supposed to be over -2.
yeah, it was. It was. Thank you.
Huh?
It was. Hold on.
Oh, she did.
Yeah.
And then the last one. Wait,
Thank you.
Is down 3.
It is. Down 1, 2, 3. We're straight off the graph. So since I'm straight off the graph, I've got to go the other direction. So I'm going to go up 3 and back. So I'm repeating the same exact bar. Up 3 and back. All right, now that's a good graph. So we got all reals, but I'm multiplying by 3. And it's not even multiples of 3 because my y values are not 0, 3, 6, 9. They're not multiples of 3. My y values are -4, -1, +2, dot, 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 dot.
She counted. She counted lots.
The y value of this bar is -4. The y value of that bar is -1. The y value of that bar is +2. That is my range. Okay, so you have a couple more to finish up on the front. The back has some review. Look at that. Oh, even a quadratic. Big time review.
I don't remember that.
Okay.
Graph the circle. We can have brackets.
Some are. So finish up the front and the back.